Hello students, welcome to LearnGuru Classes. So first of all, I would like to share a good news with you that we have made 100 plus subscribers within a span of 1 month. So I would like to take the opportunity to thank each and every one of you for showering so much of love and support to this channel. We promise you to bring more quality content with variety of subjects in the coming days. So with this note, let's begin the class. Today's topic of discussion is real numbers. As we already know what is a real number, as I have taught this in the very first introductory class. So what is a real number? Any number that signifies any quantity related to the practical world are called real numbers. So in the first class I have given you several examples of real numbers. So I am not going into these examples. Straightway I will say that real numbers exist in two forms, that is rational number and irrational numbers. So when we speak of real numbers exist in the following forms. First is rational numbers. So rational numbers, by this time you already know how to define a rational number. Any number that is expressed in the form of p by q and q is not equal to 0 is called a rational number. So example I can give as 5. So 5 is a rational number, you already know. 5 is a real number also, we can say. So 5 is what type of rational number? 5 is an integer, 5 is a natural number, 5 is a whole number, you can say. Okay, so if I talk about -2, so -2 is a negative integer, so -2 can also be addressed as a real number as well as a rational number. Next is, if I talk about 0.75, so 0.75 is a decimal expansion which is of terminating type. So this is also a real number and rational number, and we can say that it belongs to the real number family. Okay, then if I talk about 0.63 bar, so this is an example of a non-terminating and repeating decimal expansion. So this also is a rational number, and this also belongs to the real number family. And again, in a fraction, if we talk about fraction like 3 by 5, 3 by 5 is a fraction. So it is also a rational number as well as a real number. So whenever we talk about rational number, straightway we will say that it belongs to the real number. Okay, or it belongs to the real number family. So these are the rational numbers are real numbers. Okay, next comes irrational numbers. So irrational numbers, by the definition we know that any number that cannot be expressed in the form of p by q are called as irrational numbers. So like examples I can give you like 1.41432567. Okay, so this is an example of an irrational number where you have a non-terminating and non-repeating decimal expansion. So this particular example also is an irrational number, and it also belongs to the real number family. Next, if I talk about root over 2, root over 3, root over 5, etc. means any number that is under square root and which is not a perfect square under square root and which is not a perfect cube under cube root are irrational numbers, and we can say that these are real numbers as well. Okay, so irrational numbers, we can say that any irrational number is a real number. Okay, so third example is combination of rational and irrational numbers. So real numbers may exist with a combination of rational as well as irrational number. Like if I say an example such as 5 plus root 3. So 5 is a rational number, root 3 is an irrational number. So this will give you this will give you an irrational number, of course. So the irrational number is a real number, so it can be a combination of rational and irrational numbers. Another example, like I will give you 2 root of 5, 2 into root of 5 means it is a product of rational as well as irrational number. So this is also a real number. Okay, so another form by which you can identify a number that is real or not is that a number whose square is non-negative. Now what does this mean? Okay, like if I write root over 2 whole square, root over 2 whole square. So root over 2 whole square will give you 2. So 2 is a positive number, isn't it? Like if I write root over minus 5 square. So what will give you the answer? So this will be minus 5, isn't it? Root cancel, root and 2 cancel, so it will give you minus 5. So you are squaring this minus 5, right? Root over minus 5, and it is giving you minus 5 as the answer. So these numbers are not identified as real numbers because you will study this in higher classes, but still I will explain you that root over minus 5, if you write, so root over minus 5, I can write it as 5 into minus 1. Yes, you agree with me? 5 into minus 1 you can write. Now minus 1, you can write it as I square. So I square is an imaginary number notation. So these things you will be studying in the higher classes, so I am not going into the detail of that. So basically root over 5 I square, if you write, so I into root 5. So I is an imaginary notation, root over 5. So any number that is accompanied by an imaginary notation I, so that is an imaginary number or complex number, but not a real number. So for this we say that a number whose square is non-negative or positive number, like root over 2 square equal to 2. So you are getting a positive number after squaring this. But when you do root over minus 5 whole square, so you are getting minus 5. So minus 5 is a negative integer. After squaring, you are getting a negative integer. So it does not belong to real number family. So these are some of the ways or the forms in which real numbers exist. Okay, so next we are going to look into the properties of real numbers. These are the two properties of real numbers. First is completeness property. So let's read this. Each point corresponds to a unique real number on a number line, or every real number can be represented by a unique point on a number line. Okay, so if we draw a number line, suppose this is a number line. So I am starting from 0, 1. Of course here it will be minus 1, minus 2. Okay, 0, 1, 2, 3, 4. So generally for our ease we are representing the main points with the help of integers, and in between these two integers there may exist fractions, there may exist decimal numbers. Okay, so 1, 2 are real numbers, isn't it? So if I in between 1 and 2, okay, there may be numerous points. Okay, infinite number of points in between 1 and 2. So each point represented here or each point here represents a real number. Okay, or in other words, every real number can be represented by a unique point on number line. So if I name this, suppose 1 and 2 is divided into 10 equal parts. Okay, so this will be 1.1, 1.2, 1.3, 1.4, 1.1, 1.2, 1.3. All these are rational numbers as well as real numbers, we can say. Okay, so you name any point or you identify any point, so that point will give you a real number. So that is completeness property, means each point represents a real number or any real number on a number line is represented by a point, by a unique point. Okay, so this is the completeness property. Okay, next property is density property. Density, what if density, by the word density, what do you mean? Dense, the population is dense or means very close, isn't it? It's like if I will draw the number line. Suppose I am telling you this is 0, 1, 2, 3. So these are real numbers, 1, 2, 3. So in between 0 and 1 there may exist infinite number of points. Okay, in between two real numbers there may exist infinite number of points, or infinite number of points means infinite number of real numbers. So these are the two basic properties of real numbers, that is completeness property. Each point on the number line corresponds to a real number, or in other words you can say that every real number can be represented by a unique point on a number line. So that is your completeness property. And density property means in between two real numbers on the number line there may exist innumerable number of real numbers. So this is the density property. Okay, I think this is very easy. It will be very clear to you. You can easily from the sentence itself you can make out what is the meaning of this. So after that let's go to the additive property and multiplicative property of real numbers. These are the additive properties of real numbers. So first property is closure property. So what is given here? Sum of two real numbers is a real number. That is, when you add any two real numbers, irrespective of rational or irrational, it will give you a real number. Like if this is very simple, like for example, if I write 5 plus 6, 5 is a rational, that is a real number, 6 is a rational, that is a real number, and it will give you 11. So 11 is a rational number and real number as well. Okay, next is if I give you an example like 5 plus root 3. Okay, so the result will give you an irrational number. So irrational number is also a real number. Okay, another example I will give you, that is root over 5 plus of minus root over 5. So root over 5 is an irrational number, that is a real number, plus of minus root 5. So minus of root 5, negative of irrational number, is also an irrational number. Yes, and an irrational number is a real number. So root over 5 plus of minus root over 5 will give you 0. So what is 0? 0 is also a real number. So always when you add two real numbers, the result will always give you a real number. Okay, so come to the second property, that is commutative law. So commutative law everybody knows. When you add two numbers, first is A, suppose A plus B will always give you equal to B plus A. Like if I write A equal to 5, B equal to 6, so 5 plus 6 is always equal to 6 plus 5. That is 5 plus 6 will also give me 11, 6 plus 5 will also give me 11. Okay, next if I give the example, suppose A equal to root over 3 and B equal to 2. So root over 3 plus 2 is equal to 2 plus root over 3. So that is your commutative law of addition. Okay, next is associative law. Associative law means you are associating another number with the existing number, or you are adding another. Suppose a plus b, along with that you are adding another number, that is plus c. So a plus b plus c. So for that I am giving you a simple example: 5, a equal to 5, b equal to 6 and c equal to 4. Okay, so a plus b, that is 5 plus 6 and c is 4, so 11 plus 4 is 15, isn't it? So a plus b plus c, again if we go to the right hand side, so this is 5 plus 6 plus 4, so 5 plus 10 will also give you 15. So this is your associative law. So real numbers also follow associative law. Okay, very easy. Next is existence of additive identity. Now, what do you mean by the term identity? So, you have frequently heard of the word identity. Never lose your identity. Means you will never lose your characteristic or your natural behavior or your instincts, isn't it? You should not lose your identity. That means you will not be changed to some other person. So that is the literary meaning of identity. So here is that, suppose a is a real number. Okay, so when you add 0 with the real number, so it will again give you a real number. Okay, suppose if I add a plus b, a is a real number, along with this I am adding another number b, so it will always give you c. Okay, if it is a non-zero number, if b is a non-zero number, so it will always give you c. Means what? A will not retain its identity, isn't it? It is changed to another number c. But when you add a 0 with a, so it will give you the same number itself. Means it will never lose its identity or its characteristics. Okay, so for that this is called as existence of additive identity. Okay, so next is existence of additive inverse. So additive inverse, any number, suppose a, what is the inverse of a? Inverse of a is nothing but the negative of a, that is minus a. So a plus minus a. Okay, so this is plus minus, that is a minus a will give you 0, isn't it? So this is called as existence of additive inverse. So real numbers follow all these properties or additive properties. Okay, so let's look into the multiplicative properties of real numbers. These are the multiplication properties of real numbers. So first is closure property, as similar to the additive property. So first is product of two real numbers is a real number. Like if I write 5 into 5, it gives you 25. So 25 is a real number. If I write 2 into root 3, so it will give you an irrational number, so that is also a real number. So when you multiply two real numbers, the result is always a real number. Second is commutative law, that is AB equal to BA, A into B equal to B into A. So if I write A equal to 5 and B equal to 3, so 5 into 3 is also 15 and 3 into 5 is also 15. So that is a commutative property. Again, let us take combination of rational and irrational number, like 2 and this is root over 3. So 2 into root over 3 will also give you the same result as that of root over 3 into 2. So this is your commutative law of multiplication of real numbers. Next is associative law. Associative means you are just adding or multiplying another number, not adding here, multiplication, another number with the existing numbers, like AB into C, A into B into C. So for this, let me take the example like A equal to 2, B equal to 3 and C equal to root 5. Okay, so A into B, so A into B, that is 6 into root over 5, and this one A into B into C, so A is 2 into 3 into root over 5, so this will also give you 6 root over 5, this will also give you 6 root over 5, so this is associative law of multiplication. Next is existence of multiplicative identity. So multiplicative identity means the same thing, when you multiply a number with any other number, so the result will give you the same number. So when is it possible? When you multiply any real number with 1, it will give you the same real number. So that is your multiplicative identity. Next is multiplicative inverse. So any number, suppose A, so the multiplicative inverse is 1 by A. So A into 1 by A will give you, A will get cancelled, so it will give you 1, that is unity. So that is your multiplicative inverse. So real numbers also follow multiplicative inverse characteristics. Okay, next is distributive law. So distributive law means what? Suppose you are B plus C is within bracket and A is outside the bracket. So means what? You are distribute. Distribute means what? You are, suppose an apple is there, you are distributing this apple to 5 members. Okay, so here also same thing, you are distributing A with B and you are distributing A with C. So A, B plus A, C. So let's check. Suppose A I write as 5 and B I write as 3 and C I write as 2. So left hand side let us 5 into 3 plus 2. So 5 into 3 plus 2 is 5, that is 25. So again let us take the right hand side, A into B. So 5 into 3 plus 5 into 2. So 5 into 3 is 15 plus 10, that is 25. So it also follows distributive law. You can do the same thing with irrational numbers as well, but I am not going into irrational numbers. Okay, let me take another irrational number like root 2, but it will be little bit difficult for you because root 2 you have to calculate this. So no need, when we will solve the sum, that time we will see the how distributive property works for irrational numbers, combination of rational and irrational numbers. So this is your distributive law, and these are the multiplication properties of real numbers. So next class we will be solving numericals on real numbers, as how to simplify the real numbers. One big expression is there, how to simplify it, how to add real numbers, how to multiply real numbers using, you will be using these properties also to simplify the problems. You will be using distributive law. Okay, so these things will be covered in the next class. So today I am ending the class here. So if you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and relatives. So thank you so much. Bye bye.